steal his dog and now it's Snake?
I almost wrote that in my notes.
I did.
Alright. Exponential growth and decay.
I'll show you that one. I've been here here one more time.
Alright, exponential growth and decay. Okay, so most of the time when we're talking about real life stuff in algebra, algebra 1, whatever, we try to go follow a linear model, like you make $8 an hour. So every hour you get $8. Or your car payment is $230 a month. So every month it's minus $230 off of whatever. Okay, so that's linear. Everything changes is exactly the same. But a lot of times in real life, some things that happen don't happen linearly. They happen exponentially. They follow more of an exponential model. Okay? They grow, populations grow exponentially. They don't grow, it's not like your city population will grow 2 people per year. That doesn't happen. Usually, like, cities will double or they'll triple or whatever. One thing that we used last year when we were talking about this, if we told everyone in here, just in here, a secret you can't tell, and then everyone in here told exactly 2 people, so let's, for sake of easy math, let's say there are 20 people in here. If each of you told 2 people, then how many would know?
4.
Well,
60 counting you. And then if you waited an hour and you couldn't hold it in anymore, and those 40 people who now know couldn't hold it in anymore, and they told 2 people themselves, now how many people know?
Pretty sure you got half the town to know right there.
Yeah. Well, okay, let's just talk about it. Let's say you just told one person. Okay? So we started out with 20 people in this classroom, and you each just tell 1 people in an hour. So now how many people know? 40. These same 40 people can't keep their mouths shut. Okay? So each one of these 40 people tell another person. Now how many people know? Another hour passes. Another hour passes. And another hour. And another hour. Yeah, so let's see, 1, 2, 3, 4, 5. Within 6 hours, the population of Leechville knows whatever this secret is. Okay? Yeah. Right? Is that kind of how it works? It probably moves faster now if you have Twitter, right? So, and Snapchat and after school and whatever else you have. So, you have everything. Everybody knows now, right? Okay, so that's exponential growth. So we're going to talk about exponential growth. As far as exponential decay, where you're going to see exponential decay the most is probably in your science classes. Probably taught in chemistry last year. We talked about the half-life of carbon-based products. Did you do that last year in chemistry? If you're, yeah, you don't remember? We had chemistry last year? Is that really a class? Yeah, I did. So, anyway. An exponential growth model, if you're talking exponential growth, X, this is Y, it looks like this, okay? Boom, it shoots up, because once you get to a certain point and you're still doubling or tripling or whatever it is that you're doing, it explodes. The population explodes. Those are some awesome axes, by the way. Yeah.
Nearly perfect.
You know you want your axes to look like that. Exponential decay, oops, there's not a gap in it, but it goes the other way, it just kind of shoots down. But, let's see if I can make it fit. One thing you need to know about the exponential decay, it's not going to get into the negative, okay? And here's something that will really make your head explode. If we talk about a half-life, you half the amount, you know what a half-life, you know what a half-life is? Okay, so let's say I have 50 grams of something. I don't know what I have. but I have 50 grams of it. And it has a half-life, and the half-life is how long it takes for half of it to decay. Alright, that's a half-life. So, it takes 10 years. So in 10 years, if I started with 50, in 10 years I'll have 25. And then in another 10 years I'll have 12.5 grams. And then in another 10 years I'll have what? 6.25, and then it keeps happening and it keeps happening. If it keeps happening, there will always be something left. Always. It may not be something that we can measure because we're human, but there's always something. Because it's happening. Half. Like someone posted. Alright, someone put on Twitter, what if you got scared half to death twice? Okay, well you would still be alive.
Maybe a quarter.
Right, but barely, because that's sort of like an exponential decay. If you got scared half to death, then you have half of your life. And then if you get scared half to death again, you still have half of that. And then if you get scared half to death again, then you still have half of that. So really, the way to live forever is to just keep getting scared half to death, okay? And you will live forever, okay? You could end up like he who must not be named and not have enough person in you to actually live, but whatever. Okay, so let's talk about exponential growth and decay some more. There is a function for exponential growth and decay.
That's a T.
Yeah. It's a Alright, and I will tell you what all this, get it written down, and then I'll tell you what all of this stands for. Okay? That's n of t equals n sub 0 e to decay t. To decay t, Beth. Yeah, no, not really. We had our shoes on the wrong feet all day yesterday and kept telling me, I don't care, I like it. Okay, freakazoid, whatever. Yeah. Okay. So, this is your amount that you have. This is the amount. Either the amount that's left or the amount that you have at this point after it's growing. Okay. N sub 0, that's your initial amount. And E is a number. Okay. E is that number. It's the inverse of natural law. E is a number. And because this is a continuous growth model or a continuous decay model, we use E. Okay? Do you remember? I think actually we're going to talk about it in just a minute. Yeah, we will. We'll talk about interest, so I'm not going to say that just yet. Alright, now K is your constant. And we don't know what T is, right? Time, yes. Alright, now if K is positive, then it's a growth. And if K is negative, it's a decay. Alright? K is positive. Do we need to write that down? Alright.
I have so many K's to balance at this point. Like physics, I have like 6 things
Yeah.
to take, and then I have another one.
Mm-hmm. Alright, does everyone have this written down? Not yet? Yes, no, maybe?
Yeah.
Okay. Alright, so now we're going to talk population. So we have a population of a city that's growing exponentially, as they normally do. Okay? So this city is growing exponentially, and let's see. In 1995, the population was 16,400, and in 2005, it was 20,200. Okay? Now, right now, I would like to find. What the heck?
I don't know.
I would like to find the growth function. Okay? So I'm looking to fill out this. Alright, let's fill in everything we know. Do we know the new amount? Yeah, it's 20,200, right?
Times 20.
Do we know the original amount? What is it? Times b to the k. Do we know k?
No.
Nope. But do we know how much time it took? Okay. So we have a function with one variable. We can solve a function with one variable. We can do that. We're really good at that. First thing I'm going to do is move this over. 202 divided by 164. That's really ugly. Let's just use this. Okay. I got it started over. That first number, well, it's being multiplied, so I'm just going to divide. There's something there being multiplied, yeah. Because I need to try to isolate that k. Alright, now, I have an exponent that I do not know. So what is the inverse of exponents you don't know? Logarithm. Okay? And this is a base of e. The natural log. Right. So I'm going to say the natural log of 101 over 82 equals the natural log of e to the 10k. This one's beautiful because what happens right here with that natural log of e? Yeah, they just go away, right? So you have the natural log of 101 over 82 equals 10 times k. How do you solve for k? Divide all of this by 10. I'm just going to write this because I don't have any room to write underneath if I actually want to fit in the answer. Alright, so let's see. Natural log of 101 divided by 82, and then divide that by 10, and I get 0.0208. Did you get that in your calculator? Make sure you can push all the right buttons to get that in your calculator.
When Amy was watching my last time trying to win the Powerball, and I was like, come on, Amy. And she never showed up. I didn't know.
Yeah, like 3 people.
Everybody get that in the calculator. No, yes. What? Alright, let's talk for just a second about interest formulas. Yeah. Does everyone know what interest is?
Yes.
Sort of? Okay, you know when you go to the bank and you ask them for money and they say, okay, I will let you use my money for a set amount of time, you have to pay back that money plus stuff. They charge you interest for that, okay? And most of the time when you go to a bank, the interest is compounded. It's a simple interest, let me say that. It's not compound. No. Cards are generally simple interest, where they say, okay, you are going to borrow $10,000, I'm going to charge you 10%, so you're actually going to pay me back $11,000, okay? So cars are generally a simple interest. Credit cards, houses, other bank loans are compounded interest, which means they charge you interest every month or year or whatever. So like what you haven't paid back, you even have to pay more on, especially credit cards. Credit cards can get up to like 28% interest. Credit cards are a bad deal, okay? Let me just give you a little, let's say you put $100 on a credit card. If you pay it off at the end of the month, they won't charge you any interest, okay? If you don't pay it off at the end of the month, then let's say they charge you 28% interest. So now how much do you owe them? $128, okay? So let's say the minimum payment is $10. So you send in $10. You still owe them $118. And guess what they're going to do at the end of the month?
Interest up.
They're going to charge you interest again on this interest that you've already not paid. So it just keeps getting bigger and bigger and bigger. They're trapped. Don't get a credit card. And here's what's fantastic. When you go to college and you don't have a job, you're going to still get credit card offers. And you won't have a job. But you'll be like, I got this piece of plastic that says that I can order a pizza and just pay for it when I graduate. That pizza will end up costing you about $300 by the time you graduate. Don't do it. Don't get a credit card. Just be a poor college kid, okay? It's okay. We were all poor college kids once. It's the greatest, most fun time of your life, is being a poor college kid.
That's when you become a math teacher.
When 8 people are sharing the same package of ramen noodles, you really grow and become close, okay? You don't know squad until you shared one pizza with 30 people, okay? I'm not kidding. Don't get the credit card. Don't do it. It's not worth it. All right. Anyway.
Me and my grandpa used to fight over the pork and
Yeah.
beans.
All right. So compound interest formula.
I've never wanted to like.
Compound interest formula. The amount, okay, your amount equals your principal. You know what a principal is?
The person that gets you in trouble.
No, that's your original amount. That's what you borrowed. My car is $10,000, so I borrowed $10,000. That pizza was $20, so I put $20 on my credit card. Okay, that's principal. That's your original amount. Okay, that's what a principal is. If you deposit money into the bank, like you set up a savings account with $100, then that's your original amount. Okay. Okay, times 1 plus the rate over the number of times it's compounded to the NT. Alright, so I'll write down what those are. That's your principal amount. And then the R is the rate. Now your rate is given to you as a percent. So you have to make it a decimal. Percents are pretty, they're for show. But we work with decimals. Okay, so if I tell you it's 8%, you're not going to write down 8. What are you going to write down? 0.08. Right. Percents are just for show. Now the N is the number of times per year that it's compounded. Because you can compound it quarterly or monthly. And that's the same, and that's N for that one too, okay? And then T is the number of years. T is time in years. if it is compounded continuously, that is PERT. Principal times e to the rate times time. That's PERT. Oh, yes. This is the page where I made everyone, which we're going to do 2 pages. We're going to do book page and then page I made. And I tried to put everyone's name in a problem, and then I realized that I was getting like 60 problems because I have way too many students. So I rewrote and put like 2 names in some and just drew names out of a hat to see whose name went in the problem. So if your name went in the problem, good for you. And if it didn't, just take solace in the fact that there's not 60 problems, so your name is in one. Okay? Anyway, alright, so let's do you have these written down?
Nope.
Let's do a couple of problems. The good news is we're not going to get to it today. So let's say that we have invested, I don't know, $1,000. We'll do some easy numbers. At, there we go, 10% interest, and 2 years, and I want to do 3 things. I want to compound it monthly. I want to compound it, I think I want to do it yearly. No, I don't. Let's do it daily. And then, let's do it continuous. Okay, so compounding it monthly. What's P? 1,000. 1 plus 0.1 over
12.
why 12?
Because there's 12 months.
Right, we're doing it monthly, and n is the number of times per year. So
That should be 24 in 2 years.
12, so that's going to be, right, 12 times 2. Now that can go straight into your calculator. If you can work your parentheses right, you can get that right into your calculator. No. 12, 20, 12, 20, 39. 12, 20, 39. Okay. On daily, we're going to have, what, 1,000? What changes on daily?
20.
How many times do I do n now?
365.
365. You think it is?
It should be.
It's going to be bigger, right? Why will it be bigger?
Because you get
bigger number.
Right, because you're getting that interest off of interest more often. $12, 21, 37. Yeah, it's 98 cents more. Yeah.
in the long run, that could be.
What is this really like? Let's see what you've got in there. Okay, this 365 over times 2 needs to be in parentheses. Yeah. Alright, do continuous. PERT. So that's going to be what? 1,000 times e to the what? You're not getting the answer? Okay, I'll have to see what you've got going on. The rate is 1, and it's times 2 years. crosses. Okay. Okay. Show me where you're typing in. To the 365 times 2.
Oh,
Yeah, there you go. Alright, what is it with continuous interest? Is it going to be more or less than compounding it daily?
1 cent more.
It's 1 cent more?
Last year,
Yes.
3 cents
So how do you put this in your calculator? What's the D?
Second natural log. See, and it automatically brings up a to the whatever. 6 cents more. Not that big of a deal. We're talking like billions of dollars, and it might be a big deal.